Okay, so question number 5. Write the electron configuration for scandium. Okay, so to determine the electron configuration of a certain element, we need to follow a set of steps. So first, we need to divide our periodic table into orbital sections. So for example, S, P, D, and F are the different orbitals, and I can show how we would divide it on a periodic table. Okay, so the first two columns plus helium would be considered the S block, and this green section is the P block, and the middle transition metals is the D block, and finally the last two rows, the lactonides and actinides, is the F block. So starting from hydrogen, we move left to right across the periodic table, and we would write the row number followed by the block letter, and we would also use superscripts to show how many electrons are in each orbital. And then another step I'm going to add is when we get to the D block, instead of writing just the row number, we would write the row number -1. And for the F block, we would write the row number -2. Okay, so let's look at our example, which is scandium. First, let's find scandium on the periodic table. So it's right here, atomic number 21, and it's one of the first transition metals. So starting from hydrogen, we write the row number, which is row 1, and then the block letter, which is 1s. And in the 1s orbital, it can hold a maximum of 2 electrons. So as the superscript, we write 1s2. And then we move on to the next row. So row 2, block letter is S, and again, it can only hold 2 electrons, so we'd write a superscript of 2. And then when we move over to the P section, we are still in row 2. The block letter now is P, and the P orbital can hold a total of 6 electrons. So we write 2p6. And down to the next row, we write 3s2. And then again, we write 3p6. And then to the next row is 4s2. And notice that when we get to the D block, we write the row number -1. So it's going to be 3d. And scandium is the first element in this block, so we only need to write 3d1. So this is the electron configuration for scandium. And if we were to write this as a shorthand configuration, we would first need to identify the noble gas that comes before scandium, which is argon. So we'd write argon in square brackets, and then just continue on to write the rest of the electron configuration from there. So it's argon, and then 4s2, and 3d1. So this saves us a lot of time when we need to write electron configurations for the elements that are lower on the periodic table, so that we don't have to write like multiple lines of 1s2, 2s2. We just need to write the noble gas that comes before it, and then a shortened electron configuration. Okay, so the junior tutor said that the atomic number of scandium is 21, so it has 21 protons and 21 electrons if it is neutral. And they have the correct electron configuration. So this solution is correct.